In this video, we're going to learn how to make scatter plots using the website Desmos. So on my screen here, I have two tables, one of which we're going to do together, the other which you're going to do on your own. So we're going to look at table 1, and we're going to take this data and we're going to put it onto the Desmos graph. Table 1 has two columns collecting two pieces of information. This information comes from a friend of mine who works for DoorDash, and I asked her to share some data with me. So what we have here is 18 orders that she delivered over the past couple days, and it tells you how much the total order was and how much she was tipped for the order. So this table shows something called bivariate data. Bivariate data means that we're measuring two things. We have two variables involved, right? The two things we're measuring here is the total cost of the DoorDash order, and we're going to use X for that, and the total amount tipped, and we're going to call that Y. So we're going to go in Desmos here, and we're going to start a new graph. And then over here, we're going to click on the plus, and we're going to click on table, and we're going to type in all the data. Unfortunately, you can't copy and paste from what I can tell. So we're going to copy all the information into the table here. I'm hitting enter to go down and do the entire column of X's here. So go ahead and put in all your X's here. And then once you have all your X's, go to the Y column and just type in the numbers there. And make sure you keep them in the same order. Make sure everything matches up. Make sure you don't skip one, because the numbers that they're paired with in the X column absolutely matter. Okay, when you're done, you might not see anything on your graph. That's just because we're zoomed in a little too far. If you look at these X's here, the smallest X is about, it looks like 12, and the biggest X is 7450. So I'm going to go over here to this gear, and I'm going to say my X-axis needs to go from, let's say from 0 to 100. And now you can start to see the information, the data here, right? I'm going to do the same with my y-axis. I'm going to make my y-axis go from 0, in case she didn't get a tip on anything. I know she did. And her highest tip was, looks like she got a $15 tip. Let's do 20 just to be safe. And it gives us an option here to add labels. So I'm going to add labels. I'm going to say cost of order. And for y, I'm going to say amount of tip. All right. So now you should see all of these pieces of data represented as points. And what we have here is called a scatter plot. All right, a scatter plot is literally just taking a bunch of data and plotting each piece as a point. And when you're done, you end up with a graph with a bunch of points scattered around. That's why it's called a scatter plot, right? The purpose of a scatter plot is to try to find a relationship between the two pieces of data. So in this case, we want to know if there's a relationship between the total cost of the DoorDash order and the total amount tipped. And hopefully we should see a difference, right? If someone buys more stuff, buys more food on DoorDash, their total should be higher and their tip amount should be higher, right? Usually tip in America is based on how much your total purchase was, right? And think about it from an employee standpoint. You're carrying more food. There's a lot more that could go wrong, so you should be tipped more, right? So as you can see in the scatter plot, generally the points from left to right are going uphill. Now it's not a perfect linear relationship, right? That would mean all the points fall in a perfect line, but they do kind of have a trend of going from left to right uphill, right? So we're going to use something called linear regression here. We're going to represent this scatter plot as a line. Even though it's not a line, we're going to see if there's a line that best represents this data. And to do that, we have to type a very specific thing into Desmos. We have to type y1 with a little tiny 1 here. And to get that 1, you're going to type, you're going to use the underscore button, which is the button next to the 0. Another way to do it is to bring up the keyboard and look for the option to do subscript, which is here, right here. All right, so we have to do y1, and then we need to do this squiggle. It's not an equal sign. It's next to the 1. And then we're going to do m x little 1. That's called, by the way, the x1 and the y1, those little numbers are called subscripts. So we would say y sub 1, and then mx sub 1, and then we need to do plus b. So what we've done is we've told Desmos, hey, I want to take this data that we just inputted, and I want to represent it as best we can as a table, or sorry, as a line. I want to take the data from the table and represent it as a line as best we can. So you can see that this line does a good job of following the direction of the dots. It only hits like 2 points, but it does a good job of following the trend of the points. You can see that it gives us some statistics here. We're going to talk about those on another day, but what's important here is that you have the m and the b. You have the slope and you have the y-intercept. So the slope of this line is 0.157151. The y-intercept is negative 0.111591. So you can see that this line has a positive slope, and it's approximately 0.15 or 0.16, and the y-intercept is negative 0.11. So that's interesting. That would mean that if they bought no items, their tip would be negative 11 cents, right? The y-intercept represents how much they would tip, in this case, if they didn't buy any items. And the 15 cents or the 16 cents, the slope, that represents how much they tip per dollar. And that seems about right, right? I mean, usually when you go to a restaurant, you want to tip between 10 and 20%. So what we've done here is something called linear regression, and that's I took all these points and I told Desmos, can you do your best to represent this as a linear function? And they did. They were only able to hit 2 points, but that's not what's important. What's important is that the line passes through some points and also follows the direction of most of the points. And the line seems to be doing that, right? So that's all we're going to talk about today, is how to input values into a table and then how to represent the table using linear regression. So that's all for today.